today. So before we move into the area of sectors, I do want to just kind of review your circle formulas. So again, difference between circumference and area. Circumference is equal to 2 pi r, or pi times the diameter. Okay, so circumference you can use radius or diameter for. For our area of a circle, we use the formula pi r squared. Okay, so for area, you have to use the radius. So we are going to look at 2 examples using area formula. So we want to find the missing measures. So in number 1, we want to find the radius of a circle with an area of 95 square centimeters. So since we're given the area, we should use this formula here. Okay, that's pi r squared. Now I'm given the area is 95, so I want to plug in 95 for A, which is the area. And I am going to solve for the radius, so that should stay your variable. So from here, I want to get r squared by itself. So divide both sides by pi. I got about 30.24 after I divide it. From here to get r by itself, take the square root of both sides. And I got r to be about 5.5 centimeters. Okay, questions on number 1? All right, do number 2. Were Lizzie and Artessa absent on Monday? Was Lizzie?
Yeah.
Was she here Monday?
Didn't Artessa say she's going to be gone today?
Yeah,
Why Monday?
because then she'd be testing this morning if she missed one of the days of testing. Oh, Tuesday, not Monday. Tuesday.
Yeah. There's like a makeup test day they're not testing the day of the freshman.
Oh, okay. Mm-hmm. All right, so looking at number 2, again, you're given the area that is 196 pi yards squared, and this time you want to find the diameter. Okay, so again, I'm using the area formula since I was given the area. So I would have 196 pi is equal to pi r squared. Okay, and again, I want to solve for r, because once I solve for r, that's the radius, and then I can find the diameter. Okay, so I'm going to divide both sides by pi. Okay, when I do that, it cancels on both sides. So I end up with 196 is equal to r squared. Again, take the square root of both sides to get r by itself. Okay, the square root of 196 is 14. Now, since I have the radius, I can now find the diameter. All I have to do is multiply that radius by 2. And that would be 28 yards. Okay, questions on our area of a circle review? All right, so moving into area of sectors then. So a sector of a circle, you can look at it as a piece of pie. Okay, so that slice that you take out of the pie would be considered a sector. And we kind of went through that yesterday. Okay, it is a region bounded by a central angle and its intercepted arc. The formula that we use to find sector area is this equation right here. Okay, so to find area, you're going to take x over 360 times pi r squared. Now that x is your central angle measure. Okay, so where x is equal to central angle measure. Okay, so what you should notice here is that you have this fraction, right? We have our central angle of the sector itself over 360, that's the total circle. So we're taking a fraction of that circle, then multiplying by the area of that circle. So we're finding the area of that fraction, hence sector of a circle. Okay, so below here, again, area of a sector, you have your formula. It tells you that x is the central angle measure and the radius is r. Okay, so again, that r value in this formula is your radius. So you do have to use the radius and not the diameter. All right, so looking at our first example for area of sectors, we have a circular pizza has a diameter of 12 inches and is cut into 8 congruent slices. What is the area of one slice to the nearest hundredth? Okay, when you get problems like this, it does help to draw a picture. Okay, so I'm going to draw out this circle. Okay, now it's cut into 8 congruent slices. So I'm going to cut this into 8 congruent slices. Just how you would cut a normal pizza. Be 8 congruent slices there. Now, if the diameter is 12 inches, what's our radius? It's 6 inches because we do need our radius. Now, to find the area of one of these slices, we also need the central angle. How do you think I could find that central angle of one slice? If there's 8 congruent slices. I can take 360, which is our total circle, and divide by how many slices there are, which is 8. Okay, that will give me 45 degrees. Okay, so each slice has a central angle of 45 degrees. Now I also know that the radius here is 6 inches. So I do have all the information I need to find the area of one of those slices. So I'll just use this area formula here. So we have x over 360. Again, x is your central angle. That'll be 45. So that's how we get the fraction of that circle. Then multiply by the area of the circle, which is pi r. R is going to be 6 squared. Okay, and then you can just enter it in your calculator. we're going to round to the nearest hundredth. Okay, and you should get 14.14, and that would be in inches squared. Because it is an area, it is in inches squared. Questions? All right, then if you go to the back, I want you guys to do 4 and 5. Be careful on number 5. You're finding the area of the shaded sector. Mm-hmm. You like it better back there?
Yeah.
Yeah.
Yeah, that's a goal.
You have to what?
Oh, that's right, isn't it?
I don't know. You should write down your work so I know what you're doing. I think 7 on
My dogs are whack. They're whack.
It happens.
Yep. Yep, 6 for the first one. Is that right? How about 7? 7.5? 7.4.
There you go, Miss Baldwin. I showed my work.
That would be this area.
Disgusting. So you do that minus 2. You know what's really bad is
Well, not that
Baldwin.
angle.
in the bear.
The angle
Showed
minus
my work.
360.
No, this was the mango one.
No.
What?
This one's set up right. This one is not. Where's your shaded sector? Is this your shaded sector? Okay.
What? Sorry.
Is this one your shaded sector?
Oh, so I just.
So you can't use that central
I
angle.
see what I have to do now.
All right, I'm gonna go through 4 and 5. So number 4, your shaded sector, its central angle is 53. Okay, so that would be in place of x in your area formula. So I'd had 53 over 360. Then multiply by pi and r squared. R is 4. Okay, please make sure you can enter it correctly into your calculator. You should have gotten 7.4 feet squared. So if you did not get 7.4, make sure you can enter it into your calculator correctly. Questions on number 4. Number 5. So as I walked around, most of you use 65 for the central angle measure. That's not your shaded sector. Your shaded sector is this one right here. You need this angle as your central angle measure. So to find that angle, you'd have to take 360 minus 65. Okay, that is 295 degrees. And that would be the central angle of the shaded sector. Okay, so that's the angle you need to use in your formula. So now that I have that central angle, I would have 295 over 360, then times pi, and then the radius is 11, that number squared. Okay, try and enter that one into your calculator if you haven't already. 311.5. I got 311.5 inches squared. Okay, questions on those two problems? No questions? We're okay? If you need help with your calculator, you're not getting the same answers as I am, let me know after we're done with the notes and I can show you how to do it. Alright, moving on to number 6. Okay, so the color wheel at the right is a tool that artists use to organize color schemes. If the diameter of the wheel is 10 inches and each of the 12 sections is congruent, find the approximate area covered by green hues. Yes, I know this is in black and white, but in the picture, you do have this darker outlined portion. That is the sector you're looking at. Those are the green hues. Okay, so there are 3 of them in that section. So I need, for the area of that section, I need its central angle, and I need the radius. Well, I'm given the diameter is 10 inches. Okay, meaning the radius is 5 inches. Now, just like with our pizza problem on the front, each of these sections are congruent. So to find one of the central angles, okay, I can take 360 and divide by how many sections there are. There are 12 sections. So 360 divided by 12 is 30. Now, that is not your central angle. How many slices are in the green hues section? There's 3. So that means I need to take 30 and multiply it by 3. Okay? So there are 3 different slices there. So 30 times 3 is 90 degrees. That is your central angle. So now I have the central angle measure and I have the radius, so I can find the area of those green hues. So we have our central angle 90 over 360. Were you not listening to me when I first started the problem? Okay. Multiplied by pi, r is 5, and that number is squared. Again, try and enter this into your calculator. You should get 19.6 inches squared. Questions on 6? All right. Last two problems are writing in words. So we're not actually going to find this area. However, you could, since you do have numbers involved in it. We're just going to write out how we would find it. So when you get problems like this, it does help to write out your plan, how to find just that shaded region. So in number 7, the shaded region is these little corners right here. So how could we find just those shaded corners? What could we do? What should we do to find just those shaded corners? Kelly?
Isn't that the area of the circle subtracted by the area of the square?
So you do want to find both the area of the square and the circle, and you do want to subtract the circle from the square. Yes, good. Okay, so that's all I would have to write for this answer. So I would say find the area of the square and the area of the circle. Okay, then subtract the area of the circle from the area of the square. Now you do have to be careful when writing this. You should not say subtract the area of the square from the circle. The square is the bigger figure here, so you need to subtract the circle from the square. Okay, so if I had this as a writing problem on your test, you do need to be careful of how you word it. Does that make sense? All right, last one, number 8. This one looks a little bit funky here, but if you notice, you do have this larger half circle. Okay, we have a larger half circle. The pieces that are cut out from it are these smaller half circles. Okay, but I do have this one half circle added on, right? So what if I took that shaded half circle that's added on at the bottom there and just flipped it up to this point right here? Then what would I have to do to find just that shaded region? So if I moved this little one up here, what would I do to find just the shaded region?
Use a ruler.
No. Can't use a ruler to find the area.
I know you could find areas.
All right, what you could do, since I'm replacing this non-shaded half circle with the shaded half circle, we can find the area of the larger half circle, find the area of one smaller half circle, subtract the smaller half circle from the larger. Okay, because you're only missing one of those smaller half circles from the larger one. Okay, so in words, find the area of the larger half circle and the area of the smaller half circle. Okay, then subtract one smaller half circle from the larger half circle. Oops. Okay, questions on those? All right, then